All right, so in this video, I wanted to go over IPv6 addressing, actually IPv6 dynamic addressing. So there's three methods for a router to assign an IPv6 address to a host. Method one is SLAAC. And SLAAC is kind of the default method, if you will. When you enable a router to handle IPv6 packets, it will automatically use SLAAC unless you tell it to do something else. SLAAC basically, when you use SLAAC, you configure the interface on the router with the routing prefix, with the GUA's routing prefix, the first 64 bits of the GUA, and the router will give that information to all hosts that are connected and will instruct each host to generate its own interface ID, which is the last 64 bits of the GUA address. Method two is called SLAAC with stateless DHCP, or sometimes it's just called stateless DHCP. It's basically the same thing, only on the router you do one more additional line of configuration to signify that you're a stateless DHCP setup, and you also program it with a DNS server or a domain name, just a couple of things that you can add that the router will pass along to all hosts on the network so that they can self-configure. The hosts still configure their own interface ID as part of their global unicast address, the last 64 bits. The third method is called stateful DHCP, and that's kind of the full service DHCP method. In that scenario, a server or a router can be configured to be a DHCP version 6 server, and in that instance, all hosts are basically assigned a GUA, including the interface ID, along with DNS address information, domain address information, anything like that. And of course, it will also assign the default gateway as well. There's two different methods that a host can self-assign itself a interface ID. One is EUI64, which takes the MAC address of the interface of the host and incorporates it into the interface ID. And the other method is just to randomly generate a 64-bit number, which is more secure. This is EUI64. This is an example of how that works. Notice it takes a 48-bit MAC address down here, and incorporates it in, adds 16 more bits to get the interface ID, which is this here. And the other method is randomly generated. Some operating systems use randomly generated. I think Windows operating systems, they use EUI64. So they take the MAC address of the interface and make the interface ID in that way. Either way, there is a process called duplicate address detection, which is similar to ARP, but it will basically make sure and ensure that there are no duplicate IPv6 addresses being used. Although the odds of getting two randomly generated IPv6, 64-bit IPv6 interface IDs exactly the same on the same network is extremely unlikely. So I think it's a good idea to maybe take a look and see how this works. because in book one, the introduction course, it really doesn't go into configuration for this. But I think if you see how SLAAC works in action, you'll have a better understanding of what they're talking about in the book. So here I have a simple packet tracer as a router, and it has a switch with 4 hosts, and we're going to set up SLAAC on this. And we've got a global unicast address defined here. This is actually the first 4 hectets are the prefix. The last 4 hectets is actually all zeros and a 1, so 00001, 64 bits worth. That's the interface ID, and we're going to assign that to the interface of this router. We're also defining a link local address. Remember that all devices on a network will be assigned a link local address if you don't assign one. So it's a good idea on router interfaces to actually assign one yourself rather than having it assign itself a randomly generated 128-bit long link local address. So the first thing you do when you're dealing with IPv6 on a router is to enable IPv6 routing. And the command for that is IPv6 unicast routing. Now we're going to go into that interface, that's interface gigabit 00. To assign an IPv6 address, it's IPv6 address. And we're going to assign it this address here. It's 2001 DB8 ACAD 1::1. The /64 is just us telling the router that the first 64 bits are the router prefix. So basically the network. We're also going to assign it the link local address, and that is IPv6 address. And it's FE80::1. We just have to specify that it is a link local. No shutdown. Enable the interface. And let's fast forward in time a little bit so that's all green. Now if we go onto one of these PCs, go on to the desktop and look at the IP configuration. We change this IPv6 configuration from static to automatic. Notice it automatically picks up the prefix of the router. It self-assigns itself the interface ID, the last 64 bits of the global unicast address. And it looks to me like it is using EUI64 because it's got that FFFE in the middle there. It's also assigned itself a link local address. And it's defined the default gateway. When you're configuring an IPv6 network, typically best practice is to use the link local address of the router interface as the default gateway, not the global unicast address. Use the link local address, and that's being defined. So this is where IPv6 is very easy. We'll do the same thing on this one. We'll actually statically assign one of these. That has assigned itself another IPv6 address. Let's statically assign PC2. I don't know, maybe this is a server, something you'd want to statically, set up. So let's go into this. It's already assigned itself a link local address, which is fine. To statically assign it, we've got to make sure that we use the prefix that makes sure that it's in the same network. And we'll use the second IP address, : 2. And this is where the advantage of assigning the link local address on the interface comes into play. Because remember, on the default gateway, you're pointing it to the link local address of the router, not the global unicast address. So if we had not assigned the link local address of AFI 80::1, this router would have self-assigned itself a longer link local address. That is how SLAAC works. Anyway, if you have any questions, feel free to leave a comment below, or you can email me directly. And have a great day.